So with that said, we're gonna see now how we actually use NumPy without worrying so much about the low-level details, and that's the beauty of NumPy. So we have already done our low-level explanation of binary arithmetic, why NumPy is so important and all that. If you skipped it, that's perfectly fine. You will not need it. The reasoning was to include it was that if you are in this tutorial, you're probably looking for fast and efficient options to process large volumes of data, and that's when all those things come into play. So without further ado, let's just get started and start using NumPy as a library. So again, as I told you, NumPy is a very simple library for array processing and numeric processing. It has a few objects, numbers, floats, integer floats, arrays, and that's it. And it's very simple, but it's extremely powerful. So in NumPy, we're going to create these arrays, which look a lot like Python lists, but there are going to be significant differences. The first one is, of course, performance. If you go to the previous part when we were discussing the binary representation of numbers in Python and in NumPy, you're going to see the difference between them. So in this case, we're creating two arrays. And you will see, right, that the creation is extremely simple. The only thing that changes, we need to add this mp.array, and then we're passing, in this case, a list of numbers. This is something that we will usually be reading from external sources. Now, how can you access individual elements of a NumPy array? This works in the same way as with a Python list. You can say, give me the first element, or give me the second element, and it's zero index, like again in a Python list. Slicing works in the same way. So in this case, up A0 to something, A1 up to 3, right? It's just getting a low level, right, and high level of the index. Negative indexing and steps, they all work in the same way as with a Python list. So if you know how to use a Python list, you will know how to use a NumPy array. There is one new thing right here, differently from a Python list, and it's what it's called multi-indexing. Let's say you have an array, in this case B, and you need to extract 3 elements out of it. You need the element at the first position, third position, and last position. You can just type B at 0, B at 2, B at -1. Or, and this also works for a list, or you can use, again, multi-indexing, which is from B, I want to select the elements in 0, 2, and -1. First element, third element, and last element, right? So you pass in another list containing the indices of the elements that you want to select. And in this case, the important part is that the result is another NumPy array. It's not just individual elements, you're creating another NumPy array, which again, if you're processing, it's gonna be a lot faster. So arrays have types associated, and this is related to what we were speaking before. As a NumPy array is continuously assigned in memory, the NumPy library needs to know what's the type of the object you are storing. You can't just store, anything, a string, a number within it, because it will not be able to provide the performance and optimizations for arrays that are not consistent in size. So for example, when we create this array that only had integers, by default, NumPy selected int64. This is because of the platform. It's a 64-bit platform. You can tune this and you can select, as we're gonna see, other sizes in a second. When we created the array B that contain decimals or floats, it assigned a different type, which is float 64. Again, the default type is always 60, at least in this platform that is 64-bit, it's gonna be float 64 and integer 64. You can always change that. You can say, actually, I want these, even though these are all integers, I want you to create them using a float type. Or, as we saw in our previous video, we can say it should be actually type integer 8, so smaller integers for performance, for better performance, sorry. So Moving forward, we were also going to see a few other types, like for example, strings and regular objects. But as you're going to see, there is no point of storing these things in Numpy. Numpy stores numbers, dates, booleans, but not regular individual objects, as we're seeing right here. There is a way to store strings. It's perfectly valid, and it has its own type. Its own type, sorry, and it's related to the Unicode representation in memory, etc. But again, Numpy is usually used for numeric processing. So the idea of Numpy is that we can create multi-dimensional arrays. We can create what we had created before. This is a one-dimensional array, right? It's just one dimension. You can create matrices, which in this case they are two-dimensional. We have 2 rows and 3 columns. And Numpy has a ton of attributes and functions to work with multi-dimensional arrays. So the first thing we're going to see is the shape of an array, which is 2 rows by 3 columns. How many dimensions it has? It has 1 vertical and 1 horizontal. We have 2 dimensions. And what's the total size of the array? In this case, the total size is 6, the total number of elements that we have. Let's go 1 dimension further. Let's create a 3-dimensional object, a 3-dimensional array, which is basically a cube. In this case, for B, we have that the shape is 2 by 2 by 3. The number of dimensions is 3, and the size is a total count of elements, 12. You always have to be careful when you're creating these multi-dimensional arrays. If the dimensions don't match, like in this case right here, where we have this second list that only has 1 list in it, then the dimensions will not match, and it will just tell you that the array is of type object, and the shape is only 2. It only has 2 elements. This is 1 element, and this is another element. So in this case, we've done it wrong, basically, and you have to be careful when creating these objects by hand. So how can you index and slice matrices? We've done it for a 1-dimensional array. So we were selecting elements, individual elements. Give me the first element, give me the second element, etc. How can we do it with a matrix? With a matrix, what we're gonna do is gonna be very similar to what we did before. The difference is that now we have to account for multiple dimensions. When I do give me A at 1, is it the column at 1 or is it the row at 1? Well, as you can see, it's the row. So this is gonna be right here, 0, 1, 2, right? And there is also another dimension, right? So this is 0, 1, 2 in terms of index positions for our slicing. So here, how can you get the first element of the second row? In that case, you're gonna first select the second row, and then select the first element, and that's what you get, number 4. But there is a better way, which is by using the multidimensional selection of Numpy. In this case, you're gonna say, from this matrix, I want to select, and here you're gonna pass A, in this case, you're gonna pass dimension 1, dimension 2, dimension 3, dimension 4, etc. Right? And these are selectors for each one of those dimensions that you're passing. In this case, we say for row level, the element of position 1, the second element, and for column level, we want the first element in it. And it's the same thing as we did before. The advantage of this syntax, and keeping in mind and reminding it, is that it will also let you add slicing, right? So you'd say, I want to select everything from dimension 1, which is rows. So in this case, you say from 0 up to 2 is these 2 ones. The 2 is not included, upper limit, the same as Python. And then you can also pass other dimensions. So you say, I want to select every row. That's fine. But then I want to select from column level. I only want to select the elements up to 2. So these 2 and these 2 and these 2, right? So 1, 2, 4, 5, 7, 8. These all works as intuitive as it gets. Remember, this syntax is the important that you need to keep in mind. Moving forward, for modification, you can say, I want to assign this new array to this entire row, right? So if the dimensions match, that's just going to work. Now, 10 is equals, it's added to the second row. Or you can just use what we call usually an expand operation, which is going to say, for row number 2, I want to assign the number 99. And Numpy is going to take care of expanding it into this corresponding array given the number of dimensions that you have. So far that's selection, and it's simple. What we're going to see also is that Numpy has a huge advantage of containing a ton of operations you can perform on top of your arrays, your matrices, your multi-dimensional arrays in general. So the first one is all the summer statistic methods we have. So given an array, all these methods are already built in. The sum, the mean, the average, right? Standard deviation, variance, etc. And that also works for matrices. So in this case, we can get the sum, the mean, standard deviation, or we can do it per axis. So this is very useful. We can get here, let's compare these two. There you go. We can get the sum of these, what is this? First column, the second column, or the third column, and we can get it the first row, the second row, and the third row. So it's either this dimension 1, or it's a vertical dimension, which is axis equals 1, right? So per row, per column, or if you have more dimensions, you can just keep increasing the number of this axis, and that's just going to work as expected.